All right, getting into the lesson. Now, monomials you learned in one of the first lessons. A monomial is when there is just one term. If you would go like this, that would be a binomial or two monomials. So what we're doing today is we're adding and subtracting monomials. So we're taking something like this and adding it. Now, one thing they talk about in this lesson is like terms and unlike terms. That's as simple as, are they exactly alike or aren't they? 6 times A and 8 times A, these are like terms, all right? They both had the same literal numbers, all right? 6A and 6A squared are not, they are unlike, okay? Because the literal number is different, all right? A and A squared are two different numbers. Another example of unlike would be 6AB and 7B. All right, this has an AB, this just has a B. They're not like. All right, now it could be, for instance, 6CB and BC, and these would technically be like. They're probably not going to do this to you, but if it has C times B and B times C, that's the same. So they're technically like terms because they have the same literals. All right, but if it had as simple as, so let's say you have 6BC and 6BC, these are like. The literal numbers are the same. If you do something as little as put an exponent on C, they are now unlike. All right, you can't combine them. So what today's lesson is, you're going to have to make sure they're like, and if they're like terms, you can combine them. For instance, 6B minus 2B is 4B. So 6 times B minus 2 times B equals 4B. You have 6 B's, you take away 2 B's, you have 4 B's. All right? Now, let's say you have a problem like this. 7B plus 2B plus 8B squared. All right. They're going to get you to combine as much as you can. So what's like? This one and this one is like, but this one is not because it's squared. So 7B plus 2B is 9B plus 8B squared. That's the furthest you can simplify it because you cannot add these two together because that one is not like. All right, let's go to your lesson. So, write whether each one is like or unlike in part A. So we have 3A squared and 4A squared. All right, they're like. The literal numbers are the same, A squared and A squared. Then they take you down to, number 4. You have 4x squared y and 6x squared. Second one does not have a y, therefore they're not like. All right, pretty basic. Now, let's go down to number 9. We have 3z plus 7z plus z. Oh, good. I'm glad we did this one. All right. So, how many of these are like? Well, this one's like, and this one's like for sure. Is this one like? Yes, it is. In algebra, anytime, you never take 1 times anything because 1 times anything is just itself. So 1 is always understood in multiplication in algebra. So this here is 1z, all right? So you have 3 z's, 7 z's, and 1 z. So you add them up, and you have 3 plus 7 is 10, plus 1 more is 11z would be the answer for that problem, all right? If you would happen to reduce, say you would have a problem like 12a minus 11a equals what? You would not write 1a, you would just write a. All right, you never have 1 times anything. Let's do one more. How about we do, let's do 23. 23. So they have 8x plus 5 plus 2x plus y plus 2y. All right, so you look for things you can combine. This one's like, and this one's like, this one's like, and this one's like, and this one isn't like anybody. So let's combine your x's first. Well, actually, yeah, that's the order they do it today. So you have 8x and 2x, that makes 10x plus y and 2y is 3y. So we use that one, we use that one, that one, that one, we have this one left. Plus 5. All right. And that's your answer, because that's all the further you can simplify. You can't go together anymore. So you have 10x, positive 3y, positive 5. And that is the answer. So if you get the hang of that too, I don't think it'll be too hard. If you can't figure anything out, you just feel free to ask.